We're going to have a look at practice question set number 10 in preparation for quiz number 10. Starts with question number 1, kind of a tough question. We've got 3 charges in a row like we've seen before, but this time our charges aren't measured in coulombs. It just says minus 3q, plus 3q, and minus 3q, whatever that means. Could be coulombs, could be microcoulombs, it could be some other number or some other unit. We're not sure what that means exactly. All we know is that all 3 charges have the same magnitude of charge, 3q. It says the force on charge exerted on sphere x by sphere y is 6 newtons. A third sphere, sphere z, with a charge of negative 3q is introduced as shown in the diagram. So let's draw a diagram of what we know here, a free body diagram, that is, of what we know. We know that if this is x, y, and z, the force of y on x is to the right. It's because x is positive, y is negative. They attract each other. X is pulled towards y as a result of that attractive force. Now, x is pulled towards z as well. We're not sure how big that force is, so we don't know how long to draw the vector, but we do know that z and x attract each other. Therefore, the force of z on x is to the left. Now, we know what Fyx is. It tells us in the question it's 6.0 newtons. What I'm going to do for this question is use almost a variable value changing technique to solve for the value of Fzx, and then I'm going to combine them like I usually do when I see one of these questions with 3 charges. Let's find Fzx by first assuming Fyx is our original force, Fo, or let's just call it Fyx. My original force before I make any changes is k q1 q2 over r squared, and it's equal to 6.0 newtons. My new force, or Fzx, is equal to k times, once again, q1 q2, because the charges involved in Fzx are exactly the same as the charges involved in Fyx. But the distance was 4 meters between x and y. The distance is only 2 meters between x and z. My distance was r. Now my distance is 1/2 r. Remember, I got to square everything inside the bracket there. That becomes kq1 q2 over 1/4 r squared. And to divide by a fraction, you have to multiply by the reciprocal. So it ends up becoming 4 times k q1 q2 over r squared. We know the value of k q1 q2 over r squared. It's 6. So it becomes 4 times 6, which is 24 newtons. Fzx is 24 newtons to the left. You want to find the magnitude of the net force on x now? Then let's say the net force is equal to negative 24 newtons, because we got a force to the left that's 24, plus positive 6, because we have a force to the right that's 6. That ends up giving me negative 18 newtons. The magnitude of that force is C, 18 newtons. There are other ways to solve this question as well. That's just the way that I ended up solving that question. Next question, number 2. Flip the page. We see that multiple choice number 2 and numerical response number 1 both go with the information on the previous page. We want to find in multiple choice number 2 the magnitude of the force, and in numerical response number 1, the angle that's labeled there. So how do we do this? Well, we did questions like this yesterday and the day before. We've got to draw a free body diagram first of all here. We say that the charge 1 is positive, charge 2 is positive. That means there's going to be a force to the right on charge 2 as a result of number 1. We'll call that F12, the force of 1 on 2. 2 is repelled by number 1. There's also a force upward caused by number 3 on number 2. 3 is positive, 2 is positive. They're going to repel each other. 2 is pushed away from number 3. Let's find the values of both of those forces. We're going to say F12 is equal to kq1 q2 over r squared. We've got the values there. We sub those in, and we're going to find the value of F12 to be 57.536 newtons. We'll do something similar for F32. It's going to be kq3 q2 over r squared. We sub the numbers in for 3 and 2. We're going to get a value for that force of 269.7 newtons. And then, of course, we want to find that net force, which is multiple choice number 1. We're going to draw out a vector diagram, 57.536 plus 269.7 newtons. The resultant vector that we're looking for right here is F, along with the angle theta. Using the Pythagorean theorem, F works out to be 276 newtons, and theta, using the inverse tan function of opposite over adjacent, ends up giving me an angle of 77.95 degrees, which we want to round this to 3 digits, actually. 1, 2, 3. That's a 5. So that actually rounds up to 78.0 degrees. We've just answered 2 questions in one here. We've got a force, a magnitude of the force of 276 newtons C, and we've got an angle to 3 digits of 78.0 degrees.